Okay, so today we are going to start the second phase of this topic, and this is regarding the IP addresses. So first of all, we need to understand that what is an IP address. It's an Internet Protocol address, and that is basically utilized to, you may say, it's basically utilized to uniquely identify a web page or a website. There are multiple web pages, there are multiple websites when it comes to the internet or the world of the internet. So each and every web page or each and every website is basically identified by a unique address. Now, this address may be in the denary form or it might be in the hexadecimal form. Like you guys may have seen this sort of the thing. Let me show you. For IPv version 6, you might have seen this type of thing. 192.168.0.1. Now, this is an IP. And this IP may be of 32 bits or 48 bits. Let me show you how this is of 32 bits or 48 bits as well. So just give me a second. Okay. So over here, it's represented over here. It's an example for 192.168.0.0. Now, if I'm going to write each and every decimal or the denary number in 8 bits. So 192 is the representation of this, 168 is represented in that particular manner, then 0, and then again it's a 0 over here. Okay, so there are 4 set of the numbers or 4 set of the 8 bits. So overall these are of 32 bits. Coming back over here, now these are of 32 bits or 48 bits, or you may say that they might be in 128 bits as well. Now, how they are in 128 bits? That's an IPv version 6. Now, to understand that what is an IPv version 6, we need to first of all acknowledge this part that we are creating multiple web pages or multiple websites on the daily basis. And when we are creating multiple web pages or websites, so there is a pool over there. Let me show you once again with that part. Okay, let's consider that this is a pool over here. Okay, that's an IPv version 4 pool. So it started to ended up. Now, what are we gonna do? Are we going to just stop creating new website or web pages? Yes, any idea, Arva, Ashina? Are we going to stop that?
Yeah.
No, we cannot stop that. Obviously, we cannot stop that. So we need to create up a greater pool, and that greater pool is IPv version 6 because it is having 128 bits in comparison to the IPv version 4 that is just having 32 or 48 bits. Am I clear over here, guys?
Yes.
Okay, thank you. Now we're moving towards the MAC address. Now, what is a MAC address? Now, when it comes to the MAC address, so MAC address is basically the media access control address, and it is used to identify a device on the internet. Whatever the device is placed over there, that is identified with the help of the MAC address. Just hold on, please. Okay, so this is basically utilized to identify a device on the internet. Like for example, right now I'm utilizing my laptop. So this laptop is having a particular MAC address through which I will be identified in the world of internet. And this MAC address is mostly in the hexadecimal format. Number one, it is of 48 or 64 bits, out of which the first half from the left-hand side is basically utilized to identify the manufacturer, that who is the manufacturer. Is it Lenovo? Is it Dell? Is it Apple? Is it Macintosh? Is it IBM or whatsoever? Okay. The second half is gonna identify the model as well as the unique number of that particular model as well, because each and every model in each and every model, there are multiple machines that are created. So the second half is gonna identify about the model as well as the uniquely about the machine. When it comes to the types of the MAC addresses, so there are 2 different types of the MAC addresses. Locally administered MAC, that means with this MAC address, a device will only be recognized in the particular domain. It won't be recognized outside that domain. For example, if I'm utilizing a device in a organization or somewhere like that. Okay, so that device will be organized in only that organization. As soon as I'm going to come out of the range of that particular organization or out of the premises of that particular organization, my device won't be working or my device won't be recognized because it is a locally administrated MAC address. When it comes to the universally administered MAC, so it is a device that can be identified in the entire world. Okay, so am I clear with both of the things?
Yes, sir. Yes, sir.
Okay, great. Now we are coming towards the error checking methods. Now, what are the error checking methods? Obviously, when we are transmitting the data from one end to another end, like for example, I am in a particular network and you guys in another network, and I am transmitting the data to you guys. So how I'm gonna be sure that the data, that whether whatever the data I have sent to you guys, is it perfectly fine or not, or is it having some type of the errors in it? So there are few of the methods to check that out. Now, number one, it's an ARQ. The other one is the check digit. The third one is the echo check. Then it's the parity check, checksum, check block. Sorry, parity block. We are going to check about all of them, or we are going to study about all of them. So starting with the ARQ, it's an automatic repeat request. Now, what does that mean? This means that if the receiver, like you guys are the receiver right now, if you are catching up my data in a and you will be requesting for the next set of the data by your own in the set time interval. What does that mean? I'm just sending you the data. Once it has been received by you, now you will be asking for me from me for the next set of the data by your own. For example, within 2 microseconds or 2 milliseconds, because this is the time interval that is set by the network administrator. So I will wait for the 2 milliseconds, and if I get the request for the next set of the data, so I will be sure or I will be acknowledged that you guys received the last set of the data, and now I need to send you the next set of the data. But if I did not, that means there was some kind of error. Either it might be the hacking, either it might be the signal distortion, or any other fact. So I need to send that particular data that I have sent earlier. I need to send that data again. Until then, until I'm not getting the acknowledgement about that particular set of the data. And that acknowledgement is in the form that you guys will be requesting me about the next set of the data. So am I clear till over here?
Yes, yes, sir.
Great enough. Echo check. Now, what does it mean? Like when it comes to the echo, so in the real world, echo means that you are going to listen same thing that you have said. Is it so?
Yes.
Okay.
Yes.
Similarly, in the echo check, the same thing is going to happen. Whatever the data I'm sending from the sender to the receiver, the similar set of the data will be reverted back from the receiver to the sender. Now the sender is going to compare both set of the data. For example, this one is A, this one is B. Now these will be compared. If they both are, if the comparison for both of them are fine, that means the data transmitted is perfectly okay. But if they are not, that means there is an error over here. I've also mentioned over here that this is not a successful one. The reason behind it, because we cannot recognize when does that error occur. While I was sending the data to the receiver, at that particular moment, the data was corrupted, or while it was coming as an acknowledgement, at that particular time interval, it was corrupted. So I cannot recognize that, so I need to repeat the complete cycle once again. So this is an echo check over here. Clear?
Yes, yes, sir.
Okay. Now we're coming to the checksum. What is the checksum? Checksum is something that it is applied over the block of the data. Now, what do you mean by the block of the data? Block of the data means multiple bytes together. Multiple bytes transmitting together is particularly known as the block of data. So checksum is applied over the block of the data, and always to remember that the block that the value of checksum should be less than 256. Now, why is that so? You guys need to understand that thing as well. The reason behind is, if I am writing over here 2 power 0, sorry, 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. These are gonna make up the values 1, 2, 4, 8, 16, 32, 64, 120. That means from 2 power 0 till 2 power 7, I have utilized 8 bits. And I said that block means multiple bytes. So a single byte contains 8 bits in all. So what will be the value if I'm gonna add all these values 128, 64, 32, 16, 8, 4, 2, and 1? What will be the maximum value I will be getting up? Yes, any idea?
256.
No. Just calculate that. Come on, people. 128, 64, 32, 16, 8, 4, 2, and 1. Just add them all together. What is the answer that you guys are getting? Yes. Come on, guys. What's the answer that we are getting? Ashina, Arwa. Are you guys calculating it? Please answer me.
Yes, in the process.
Okay.
$255.
255. Great answer. Okay, so we are getting 255. So the value for the checksum should always be less than 256. That means it should be within the range of 8 bits. Okay. Now, moving ahead. Okay. So formula. There is a formula for a checksum. Now, what's that particular formula? That formula says that checksum is equivalent to x minus z, where x is the given block size, and in this question we are provided with a block size that is 1185, whereas z is unknown to us. So to find the z, we do have a formula. Z is equivalent to y into 256, whereas we are also not provided with the value for y. So we do have to calculate the y as well, and the formula to calculate a y is equivalent to x divided by 256. Now, x is provided to us, that is 1185. So I just divided 1185 with 256. I will be getting the answer 4.629. But over here, I do need to take the whole number on. Whatever is written after the point, just neglect that. Whatever is written after the point, just neglect that. And the 4 will be the whole number over here. Okay. So my value for y is 4. Place this in equation number 2. Y multiply by 256. 4 into 256, we are getting the answer 1024. Now I need to place this in equation number 1. Checksum is equivalent to x minus c. So if I'm getting 1185 minus 1024, the answer that I will be getting is 161. Is it less than 256? Sorry, 255? Yes or no?
Yes.
Okay. So is my checksum right now?
It's right.
Okay, great. So this is how we are going to find about the checksum. Now we are going to come up with a parity check. Now what do we need to do in the parity check? Now parity check is something that you are provided with an extra bit apart from the transmitted data. and we need to write the parity over there. How are we going to write about the parity over there? So to write about the parity over there are two types of the parities. So first of all, you need to understand that the odd parity and the even parity. Odd parity is represented by 1, whereas the even parity is represented by a 0. Now, how I'm going to look forward for that thing? So this is how we are going to look forward for that. The odd parity, how are we going to find it out? We are going to count the number of the ones over here. In the transmitted byte, we are going to count the number of the ones. 1, 2, 3, 4, 5. Now 5 is 5 an odd number or an even number?
Odd number.
Odd number. So over here, what I will be writing in the parity bit is 1. Okay, the parity bit is also the sign bit. It's also the highest significant bit. Okay. If the number of the ones were 2, what should I write over here?
0.
0. Ashina, are you getting this point?
Yes, sir.
Yeah, okay. So we are done with how many of them? We are done with ARQ, we are done with the echo, we are done with the checksum, we are done with the parity check. Now we are left with 2, the check digit and the parity block. So before starting with that, I need to explain you one more thing. What's regarding that? That is the parts of the head. Sorry. First of all, you guys need to understand whenever you are sending the packet. Okay, any idea that what is the packet I just explained in the last class? Remember? Group of 8 bits is termed as a byte. And what is a packet or a chunk? Arva, Achina?
2 bytes, I think.
2 or more than 2 bytes is termed as a packet. So in a packet, there are 3 things: header, payload, and a trailer. Header, payload, and a trailer. Now, header is further divided into 4 things. What are those? Number 1, IP of the source, from where the data is going to be transmitted. IP of the destination, to where the data is going to be transmitted. Like for example, you are writing a letter to someone, so there are 2 addresses on that particular letter. The first is regarding the person who is sending that, and the other address is of a person who is receiving that. So IP of the source, IP of the destination. Size of the packet, on how many bits or how many bytes that packet is on. Sequence number of the packets. Now what is that? Okay, now when it comes to the sequence number of the packets, so always do remember that when we are transmitting a packet, so that packet breaks up into multiple parts, and each and every part is provided with a particular number. That number or that sequence number is known as a hop number, HOPP hop number. I mentioned over here as well. Sequence number of the parts of packet to rearrange it. Now, what do you mean by the rearrange it? Now, you may see that I have made a diagram over here. At one side, I have written my name, and another side, I have explained to other students, I have written his name. There are 3 paths that I have mentioned with the blue color, 1, 2, and 3. Now the parts of the packet started to transmit. 1, the upper one is 2. Let me highlight that for you. 1, 2, and 3. Okay. Now when Vase received that particular thing, so on the first path, the first transmission was received at the last. The third transmission was received prior, and then second was on second number. Okay, now in this way, my serial numbers were disturbed. So obviously my data will be disturbed as well, and that will be a corrupted data for the receiver. So he needs to rearrange it. So how he's going to rearrange that? He's going to rearrange that with the help of the hop numbers. And the process of rearranging that particular part of the packet is known as hopping. Am I clear with this thing? With the hop number and hopping?
Yes, sir.
Arwa?
Yes, sir.
Confirm? Should I move ahead?
Yes.
Okay, Ashina beta, confirm? Should I move ahead?
Yes, sir.
Okay, thank you. Now we're coming towards the parts of the payload. Now there is only a single part, that's a data. The main data that is being transmitted. Parts of the trailer. Now there are two things in the trailer. Number one, error checking method, that how this packet needs to be checked when it is received by the receiver. And other thing that determines the end of the packet, that over here the packet has been winded up or ended up or has been finished. Clear with this thing?
Yes, yes, sir.
Okay. Now just give me a second so that I can open up the book and we can do the other stuff. So just give me a second, please. Okay. Can you see the screen, guys?
Yes, sir.
Okay. So now we're going to start with one more error checking method. We were left with two, parity block and check digit. So we are coming on the second last one, that's check digit. How we're going to do with the check digit? So to do with the check digit, always remember that check digit is an additional number given at the last of the transmitted data. Mostly we are utilizing that on the ISBN numbers, or you may call this thing as the barcode as well. Okay. Now, I have just mentioned the similar number over here, 978034098382. The last digit is the, sorry. So the last digit over here is the check digit. Now, the procedure to find out the check digit is quite simple. You will be given the instructions, or you will be provided with the instructions in your paper. You just simply need to follow those instructions, nothing apart from that. Okay. So like over here, they are given over here. Likewise, they will be given in your paper as well. Number one, add all the odd number digits together, excluding the check digit. Now, what does that mean? Odd number. Now, this terminology means that odd places, whatever the number is placed on odd places. So this is place number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the numbers that are placed on odd places, so that means the red parts, 9 plus 8 plus 3 plus 0 plus 8 plus 8, I will be getting the answer 36 over here. So is the step number 1 clear to you guys?
Yes, sir. Yes, sir.
Now the step number 2 says, add all even number digits together and multiply the result by 3. That means the numbers that are placed on even places, and you need to multiply the result by 3. So if I'm going to add up 704932, this will give me a 25, and multiply by 3 will give me a 75. Clear till over here?
Yes, sir. Yes.
Okay. Now for task number 3. Add the results from 1 and 2 together and divide by 10. That means I need to add up 36 plus 75. I will be getting the answer 111. I need to divide that by 10. So I will be getting the answer 11 remainder 1. 10 11s are 110 and the remainder is gonna be 1. Now it says, take the remainder if it is 0, use this value. That means if my remainder was 0, then this value is fine with me. But my remainder is not 0. So I need to go to the other situation, that's the otherwise situation. Otherwise, subtract the remainder from 10 to find the check digit. So I need to subtract 1 from 10 and coincidentally, we are getting, or by chance, we are getting the same value as it was provided to us. So over here, we're going to write that check digit is 5. Clear with this one?
Yes, sir. Yes, sir.
For an example, if we were getting 8 as a result, it was remainder was 2 and we were getting 8 as a result. So you will be writing that the correct check digit is 8. Good enough? Am I clear?
Yes, yes, yes.
Okay. So now we need to go to the last thing, that it's parity block. Okay, now as I told you guys that the block of the data means that multiple bytes. Now over here, this is a question of a parity block. How are you going to do that? You just simply need to do the thing that we have done in the parity check. Let me revise that for once again. So for parity check, we were over here. We just counted the number of the ones, and for the odd parity, we represented by it by 1, and for the even parity, we represented by 0. So we need to do the same task over here as well. But over here, there are multiple bytes. So we need to do it twice. One for the row wise and the other one for the column wise. So for the row wise, we are starting with number 1, byte number 1. So for byte number 1, the parity is given to us 1. Now just let me know that that the number of the ones in this row should be odd or even.
Odd.
Odd. Okay. So now count the number of the ones from bit number 2 till bit number 8. You do not need to count the parity bit because it's an additional bit. Okay. Yeah. So how many ones are there?
5. 5.
5 ones. Okay. Great. So is this bit byte correct or wrong?
Correct.
Correct. Now just let me know about byte number 2, 3, 4 till byte number 7. Are they correct or are they wrong? Just let me know. Come on, be quick. First of all, byte number 2, is it correct or wrong?
Correct.
Both of you agree about that?
Yes, sir.
So byte number 2 is correct. Similarly, byte 3, 4 till byte number 7, they all are correct. But when it comes to the byte number 8, so please let me know whether is it correct or is it wrong?
So wrong.
It's wrong. Why is it wrong? Because it's mentioned over here 0. That means number of the ones should be even over here. But how many ones are we having over here? 1, 2, 3. That means we are having odd ones over here. So the byte that is wrong, what we need to do with that? We need to highlight that particular byte. Okay, we highlighted this one. Now we need to check it for the byte number 9 and for the byte number parity byte. So I'm telling you in a quick span that it is fine. They are correct. Now similarly, we need to do the similar task for the column wise as well. But from where we need to start? We need to start from the bottom to top. It's 1 over here. That means how many ones should be there in this column? So starting from byte number 9 till byte number 1, just count the number of the ones. Are they odd or are they even over here?
Odd.
They are odd. That means this parity bit is fine. This column is fine. Now we need to check for each and every column. Only bit number 5 is wrong. So we got a cell over here that is intercepted. That means there is a single cell over here that is wrong in the row wise as well as in the column wise. So when we are going to detect the error, so to detect the error, we got around 1 to 2 marks. And the second part is that how are you gonna correct that error? So for this question, you're gonna write the answer by changing bit 5 of byte 8 from 1 to 0. If I'm gonna change this 1 to 0, so my both problems will be solved. Is it so?
Yes. Yes.
Okay. So we can do this if we are getting a single error. But what if we are getting multiple errors? We are not provided with a lot of space. So we need to write by changing the values of all the intercepted cells from 1 to 0 or 0 to 1. If it's a 1, just change it to 0, and if it's a 0, change it to 1. Is that clear?
Yes.
To both of you?
Yes.
Okay, so we are done. Alhamdulillah, we are done with the data transmission over here. Now, in the next class, we will be starting with the hardware topic, and that hardware topic we will be starting with the memory and data storage. Okay, thank you so much, guys. That's all for today. Allah Hafiz.
Sir,
Yeah, please.
the file you sent on the group, it isn't
No, no, please.
opening.